Hi, I'm Donald McIntyre, Senior Editor at the ETC Cooperative. This is the Ethereum Classic Course, Class 3, the first digital currency attempts. Cypherpunks Review. In the previous class, we discussed that Ethereum Classic ETC and its incredibly secure and versatile functionality is the product of decades of work by people who saw the potential of public key cryptography to create an internet free from centralization, capture, and manipulation by special interests. These were the cypherpunks. In this class of the Ethereum Classic course, we will explain how their first digital currency attempts worked and how they form part of Bitcoin and Ethereum Classic. Adam Back and Hashcash. Hashcash used proof of work, the heart of the technology in Bitcoin and the heart of the consensus mechanism that ETC uses today, as a way of blocking spam in a peer-to-peer email system. The way it worked was that the sender email server had to do a lot of work before sending the email and had to post a proof of work stamp on the email for the receiving server to verify that the work was done. If, for example, the work demanded was 1 minute of computational cycles per email, then for any attacker to send, say, 1 million spam emails, its server would have to work 1 million minutes to be able to perpetrate the attack. This would, in practice, enable a peer-to-peer email system with little to no spam. So the original use case for proof of work created by Adam Back was to prevent spam on the internet. And the way it worked then, the sender would have to create a proof of work hash or stamp, which looks like this. When a computer has to do a lot of work in a proof of work system, the end result is a stamp or a hash or a proof of work stamp that looks like this. So the sender would put this in the email. They would write the email normally and say at the footer put this proof, and the receiver machine or the receiver client would receive it, verify that this was legitimate, that they actually did the work, and if they did the work, then they would accept the email. And that was the method. The important thing is that the sender had to do a lot of work. Nick Szabo and BitGold. When Nick Szabo read about Hashcash in early 1998, he immediately established the connection of the proof of work stamps with digital gold, which is an analogy of gold in the real world, but applied to the digital world. With this idea, he created a system called BitGold, which became a precursor of Bitcoin and thus ETC. BitGold puts to work a group of machines in a network to create proof of work stamps, and each one of these stamps is treated as digital gold. This method ensured that the creation of the proof of work stamps would be very costly, as real gold is very costly to extract from nature, therefore making BitGold proofs a sound type of money, but on the internet. So this is the key connection that is important to understand. Nick Szabo said, okay, this stamp that is the product of time and electricity spent by a machine and therefore a big cost money in capital. This, we could say that a machine spent $1,800 in amortization of the machine plus electricity to create this proof of work stamp. We could say that an ounce of gold, which is worth more or less $1,800, is analogous to this proof of work stamp, because in the real world, an ounce of gold, if you think about it, is a proof that miners in the world had to spend a lot of money, more or less $1,800, to extract this little ounce of gold. So miners on the internet are similar to miners in the real world, but instead of creating these proofs, which are ounces of gold, they create digital proofs that are inside the internet. That was the key connection that later became extremely important for Bitcoin and then Ethereum Classic. Wei Dai and B-money. Wei Dai discussed the idea of proof of work and BitGold with Nick Szabo in early 1998, and in late 1998 came up with the idea of B-money, a variation of BitGold. The way B-money worked as a network protocol was very much how Bitcoin was designed, and it is also a peer-to-peer and monetary reward method that Ethereum Classic uses. Basically, of all the nodes in the network, a subgroup called miners would create BitGold and then send it to the rest of the network for verification. Once the rest of the network nodes confirmed that the proof of work stamps were legit, then they would credit the accounts of the miners in the ledger they managed, units of a digital currency that was issued for these purposes. So this is very important because it's basically how Bitcoin worked in 2009 and it works today, and it's how Ethereum Classic works as well. The way it works is B-money works is that, okay, you have this whole network, and some of the nodes in the network are miners, and they work and spend a lot of electricity, and they put a lot of machines to work, and they create these proof of work stamps according to the protocol. And then they send these stamps each time they create one to the rest of the network, which are other nodes that are just verifying nodes. And when these nodes check that the proof of work stamps are legitimate and that they actually put in the work, then they would all credit in a ledger that they all manage collectively, because they all have a replica of the ledger, in the accounts of the miners, a new digital currency reward, a currency that was invented just for these purposes. In the case of Bitcoin, 6.25 Bitcoins are issued every block. New Bitcoins are issued every block to pay for miners. And in the case of ETC, currently is 2.56 ETC issued for these purposes. So you have on one side the BitGold, which is the work itself, but the BitGold didn't turn into the actual monetary asset in the end. What they did is give me the proof, and then I'll credit you a token or a cryptocurrency to pay you for your work. So it was divided in two. BitGold was divided in the proof on one side and the digital asset on the other. And this is how Bitcoin and Ethereum Classic work today. Hal Finney and RPOW. Hal Finney also tried to create a proof of work monetary system based on the BitGold model that he called RPOW, which stands for reusable proofs of work. Like Hashcash, BitGold, and B-money, some of RPOW's design was incorporated into Bitcoin by Satoshi Nakamoto and also forms part of ETC's blueprint. RPOW consisted of a centralized verifying server that would confirm that the proofs of work sent between users were legitimate. Users would create their own BitGold in their machines and then send them to others by email as payments. The system did not take off because the central server was a point of failure, but the verification process was a key contribution to the industry. So this is RPOW. It was not really a network, it was just independent machines. You could have your own machine, your own node, or your own RPOW software, create BitGold, and then send it by email to others, like Hashcash, that you would send the stamp, the cryptographic stamp by email. And the receiver would verify with this central verifying server that the Hashcash stamp was correct, and then it would accept as payment for something. So it was an email network that would transfer BitGold directly. It didn't create another currency like B-money. But the verifying model was the important part that was used by Satoshi Nakamoto. Bitcoin and Ethereum Classic. What Satoshi Nakamoto did was to integrate all these pioneering ideas into Bitcoin, and then Ethereum Classic adopted the majority of Bitcoin's model for its base security. Ethereum Classic is the same as Bitcoin in the base. It uses proof of work, the same consensus mechanism, the same reward system, highly secure in its philosophy, but it adds a layer of smart contracts, which is programmability, which is the difference with Bitcoin. In the next class, we will explain this in detail. Thank you for watching this video, Ethereum Classic Course, Class 3, the first digital currency attempts. And if you want to learn more about Ethereum Classic, please go to ethereumclassic.org. Thank you very much.